this time. Let's see. But I did do a calculation. I am spending like about 2 billion tokens a day, I guess. I just use max plan, so I didn't realize.
So I literally just started poking around with like mitocodex too. But like, what is like the biggest like value that you think?
One is like I was struggling with like actual tmux management, and they just really did a good job. And the other thing is their prompts in there. They have done like an amazing job of like doing pipelines. So if you use, I use the RAL plan, which is like the Ralph planner all the time. And basically now you'll see like it'll produce like 3 tickets, and I'll just be like, yo, create Ralph plans for 3 of them. And I find the Ralph plans to be like really very good. And then it also has, I wouldn't do this because the tickets I'm showing you now are like security projects. So like I actually need to look at them, right? And unfortunately I don't have any good ones, but like for a hub project where it's like front end or like app, you can even, they have like an autopilot, which will do like a Ralph plan. They'll do the whole thing. Then it'll do programmatic tests. And then finally it'll smoke test like by itself. I'll go from the beginning to the end, like all on its own. So you can open up like 5 tabs, be like autopilot, Ralph plan, whatever. And it's actually got me to like where I've seen some other people in the group where like I'm literally running like 10 codex threads. And then they have in the middle of the plans, you can actually throw off like a team. Okay, so fire now. Let's see if I feel comfortable doing any of these right now. Single scoped hub SSO ticket. No, I can't do that. I gotta see that myself. Session timeout review. All right, that seems fine. So let's do that. It's just a review. T48 and T.
Aditya, would you mind zooming in just like a few pluses, just so that we're not streaming on X anymore. I couldn't get it to work, but I'll upload the video for everyone's viewing later.
And let them know how my platform works.
Like, and then after you do this, if you could do like a 30-second recap of like, here's what I'm doing, whatever.
Okay.
Just so it's for the new joiners,
Yeah. Okay, and T47 are all review only. So let's do those first. Put the plans to review for me in the hub, please. And then I can go to all the teams. Our team, there we go. Now it should, if it picks it up correctly, actually just split into like 3 tmux panes and just start firing off the whole team. Let's see. It's got to think on its own.
Is this similar to like Claude's teams where they talk to each other, or is it more?
Yes, quite similar. Okay, but I've found that they have, so like there was this guy, Geoffrey who did like agent mail. And I really liked the way agent mail worked, but it was like 40 MCP functions, so like I couldn't use it. So these guys have done a really good job of like message passing and waiting between the orchestrator and the team members. In this case, the team members are not doing like really related tasks. Oh man, why didn't it open the? Why didn't it open the? Oh, it's still exploring each one separately. Yeah, I don't know why I didn't open the 3 panes. But normally it just takes my tmux over and like it opens up like 3 little boxes. You can see the different team members.
Would it still figure out to do this kind of split with a bunch of subagents if you didn't put in the magic team kind of marker, or like you have to kind of guide it a bit?
It definitely wouldn't do it where there's separate tmux panes, for sure. I've tried to do that many times myself, and I've always got lost in like this PTY versus TTY like land. I've seen a bunch of different people have solutions to that problem. Like the OpenClaw guys wrote ACPX, which is pretty cool, but didn't work perfectly for me. But I do use it when I use OpenClaw. And then another friend of ours, Travis, Travis Klein, he's written his own thing called IT2, which controls that IT terminal, like the iTerm or whatever. It does a really good job of orchestrating that, but I don't use that. So I've been looking at like other solutions that like almost do this. But then these guys, they just crushed it. So now it's actually gonna run all 3 at the same time, I hope. It says team 3 executor, so why haven't you opened them up yet? I don't know, because some of these repos are dirty. All right, hopefully it'll like get through it and commit or stash before opening up the team.
I guess I'm curious. Oh, sorry.
Yeah, go ahead.
I was just wondering, like, how do you like manage the complexity of this? Like, do you look at the code at all, or do you? I mean, it seems like you have like a planning thing and like a review workflow.
Yes. So right now I'm having them write everything, and then at this time they didn't do it. I guess my skills are not good enough. Normally they remember to put them in progress, and then for these tasks, I'm telling them to like write me a plan and I'll review it. That the task is just a plan. So I am very much going in like waves.
Yeah.
And it is a challenge. It feels like it's faster, but then sometimes you'll go through and write a ton of stuff, and you'll just be like, "Sark lecture is a maze," and have to start over.
Yeah.
So yeah, that does happen more than I would like, but on balance, I'm actually very, very pleased with the amount of things. Like I would never dream of like making my own Notion clone and then shipping it to like 20 customers, and making a Slack clone and hosting the two and having them work together. Now I feel totally comfortable with all of that. The only thing is sometimes it makes these design decisions that, I don't love, and then having to fix them involves like a ton of refactoring, like way more than I was expecting.
Yeah.
Like 2 weeks can go by like refactoring. So it's like a different thing, but on the other hand, the productivity is there. And because I'm hosting OpenClaw, there's a lot of like security and infrastructure stuff, and we've been able to get through that too. But that stuff, it does get confused. I just don't think they're so good at like thinking about a whole network yet. These agents.
What do you do on the security front with the open source?
I mean, it's more like I'm also learning as I go, right? Basically, like now, almost everything that I do that's like real, like from OpenClaw to something else, goes across like a VM boundary. So it's like when you do like a tool call, it'll actually be executing another VM. And then if it has credentials, it may go through like one more, like sensitive ones. So like our integration to like Gmail and other things will be like living in a separate VM, and then your tool execution is another VM, and then your OpenClaw is in a third VM. And that's basically the general principle. And then trying to get keys across them, you actually need to hit like a broker, the SSHCA, and a lot of the approvals are out of band. Like I'll actually get a text and like approve. Because otherwise it's that shy little thing or whatever, right? It's just nuts out there. Light LLM, blah, blah, blah. So yeah, I don't know if you guys really want to watch this.
Watching the text.
I don't usually, right? I go and do something else.
All right, so for the new joiners, Aditya, could you just give like a 15 to 30 second elevator pitch of what you just demonstrated and why it's important?
So I have a Vibe Kanban right here and a wiki that I wrote that is all thanks to hyper-engineering, right? And it's got this whole backlog full of tickets. So as an example, I was just like, find me the tickets in here that don't involve like code that gets deployed, because this is an app security project, but that I'll just like review. And I jumped into Oh My Codex in the terminal inside Tmux on my VPS. It's all on the same VPS. And Oh My Codex, it came back with like, we found 3 together that are just review only, like it has to build a new architecture, write a plan. And I was like, do them all at the same time. And Oh My Codex opened up these 3 Tmux windows, and it's got 3 teammates who are all individually doing the 3 different tasks. And I just did this to show like my general workflow. Ordinarily, if this is like app focused, I would actually go ahead and like actually ship it like all the way, or like review it in a work tree or branch or whatever.
Wait, one thing that I've been struggling with is like mobile development. Do you have anything so that you can like work on the VPS on your like mobile phone?
So unfortunately not yet, but through ACPX, OpenClaw is not bad at controlling Codex or Claude Code, and all my skills are in Codex and Claude Code. So I can actually instruct this OpenClaw like, hey, do something with ACPX, and if it's small enough or like researchy enough, it's fine. But I'm not able to integrate this Tmux session with my OpenClaw on the go yet. I've been searching for that. That's the next piece I guess I'll get to.
I started using this thing called, I think it's Moshi or whatever, and it lets me run
mobile shell,
mobile, but I just hate the interface. Like I just hate it so much.
I can't use a terminal on my phone. I have to like talk to something, and I actually drive now because I moved to Silicon Valley. So like I really want to program like in my car too. Like not a lot, but like if I remember something, I would like add a message, you know? Yeah. So unfortunately not found that yet. But close. ACPX is very nice technology. It just doesn't bridge the Tmux session to like, that's it. But in terms of you actually just want Codex to like do a thing, it'll actually send the instruction, which is very hard for.
Hey, somebody join.
That is Jason. Okay. All right. So Jason, could you put some headphones in?
Yeah.
Figure out how to mute him. Okay, he's good. Right. Woo! AGI won't solve that. All right.
I got a question. One more question. So how are you thinking about like all of these random features for your workflow? Like at one point, you talk to your computer, and at another point you said like, oh yeah, and then I approved something from my phone. Like did you just build that? Did you just like, oh, I want to talk to my phone, and you said just build that, and you had the feature in 5 minutes? Or are you like, these are things that everybody else is doing, and then you're picking and choosing the features? Or I'm just having a problem where there's so many tools out there, and like 90% of them don't work or something, and I'm trying to think like, do I just say AI, okay, make it work, or do I have to build this stuff all on my own, or what are your thoughts on that?
Yeah, I think everybody's pushing for the same thing where you could like have like an open claw or like some sort of lightweight, very friendly agent like control your TMUX session when you're away from your computer, right? Because your open claw is really good at talking to you. Like you can send a voice notes, you can message it, and if it could just hop into the TMUX session and like look at stuff and tell you what's going on and enter a few messages for you reliably, that would be like my, I guess, canonical dream right now. But I haven't found like the right set of technology that lets me do that. Because like just TMUX, PTY, TTY, yes. So one solution is just get a bigger phone. But that doesn't work for the car, right? So if you're driving and you want to talk to it, how are you going to do it? So, I don't know, Jason clearly has more ideas, which I'd love to hear. But yeah, so I think like Peter and Vincent, like the OpenClaw guys themselves must be doing this, and somebody, but I haven't seen anybody do this perfectly yet myself. So, but it is what I'd like to find out next. I think there might be a way for like a background agent over ACPX to be reading the logs from TMUX, and then I can control it from behind. It still wouldn't be like crazy user friendly, but because I know how the architecture is, I could probably manage it. But I hate the experience when you're like talking to it, and then you think it's done all this stuff, and you come back and you look, and it's done something completely different. And that drives me nuts, especially because, we work so much in prod these days. So it's like, not really the best idea. So yeah. Still looking for that final piece of getting away from the screen.
Cool.
Myself. Yeah.
If anybody has one more question, we'll do it. Otherwise, we'll hand it over to Jason. It's been Jason's work. If anybody's part of the group chat, you've seen him Vig post about amazing Chinese models, and he will finally demonstrate exactly what he's talking about. And if you're not part of the group chat, you would like to be, just show me or tell me your bill, how much you're spending per month. If you're above the new threshold, then I'll give you admissions. But we try to keep it very tight and top 1% so that we can I don't know, destroy the environment with token spend. So also welcome Jeff Huntley, the famous author of Ralph Loop. Good to see you. We were just talking about, or Aditya was mentioning how he has it set up. It's good to have you on the call.
Planning. Yeah,
hello.
And Ralph coding too. Amazing.
Hello. I'm currently over in Lithuania. I'm 35 days and 95 days of keynote talks. So it's 4 a.m. here.
Woo! Thank you for joining.
So that's all right. Always happy to hang around with other token slop lords. It is what it is. I think I've generated so much code, I don't know what to generate anymore. So I'm building a unikernel operating system, and playing around with ideas that like maybe we could, instead of building, we cut. It's a little bit inverted, but yeah, to your question, probably, I don't know, I think I spent maybe 800K US in tokens in the last year.
Wow, nice. I think that might be the high score actually, unless Jason has something to say about it. He was previously the high score holder, but actually I got a text message today. Somebody just sent me a bill from Anthropic, $1,246,000. So I don't know if that was per month, but that's a big bill.
Yeah, it's funny because there's categories and categories of people out here we've used this for exploration, and this has got us really good at I like to see LLMs as a musical instrument, like a guitar, and A lot of people are assuming they can just pick up the guitar and get good. No, you got to burn tokens to learn the sounds of the LLM or the guitar. And it's so many people just don't understand this.
Yeah.
So many people don't understand this. To your previous question, Mosh is a fantastic replacement to SSH, or it's used as a side channel to SSH. If you do any world traveling, it's the thing that makes the internet work. If you're on a sailboat, you want to use the internet. So use Mosh with SSH and it will allow you to, on your phone, it's table stakes. My workload these days is a little bit vanilla. I've chewed enough tokens that vendors tend to give me free access to tokens. So right now, Cursor is like, you could use as many tokens as you like, and Cursor, without a doubt, has the best mobile UX, and I'm addicted, but their pricing is ridiculous. But the computer use and everything works really well. But yeah, normally it's either like a terminus from my phone with Mosh, or like this month it's Cursor, and next month I don't know what it's going to be. It keeps switching. And to the other question, you should consider these tools to be an expression of taste. When you use someone else's harness, you're consuming their taste. So if their taste is high, then that's good to consume, but otherwise it's so easy to build it. You should just build your own expression of taste. And I think all hyper engineers will eventually converge to building their own expression of themselves.
Well said. Out of curiosity, how on Cursor alone are you able to rack up such a high spend on the mobile? Are you using parallel agents? Are you doing long running tasks? The computer use thing is amazing, by the way, if anybody's tried it before. It makes like little demo videos of the app actually working.
I'm addicted to it.
Yeah,
I'm addicted to it. It is so good.
It's quite good.
Cursor implemented Ralph. It's called grind mode. Probably about 2-3 months ago. And that's good enough for me just to like, I've got an idea, let it long running. And they did a really good job with the memory management. Ralph is always about, context engineering is about the allocations of memory, or more specifically, not allocating memory. And they do a really good job of implementing it.
Mm-hmm.
So I use that. It's so simple. And I think that's going to be, I spent a bit of time thinking about like the people who are not us, like how, like, well, what is accessible, and they don't want to have to think about context engineering and all these things. And yeah, Claude Code's doing a pretty damn good job these days. But if you look at it from the right angle, it's rebuilt Erlang and the OTP.
Cool.
If you think of tokens like gas, like, do you try to measure miles per gallon with your tokens? Like, does that make sense? Like, can you spend tokens on like just trying to find the efficient path to the route?
Yes, actually, I think of tokens as an expendable resource because you can just use however many you want if you know how to do it. And then as long as you get the right result, who cares how many you used? The number is irrelevant. In the last 24 hours, I spent 25 trillion tokens.
All right. Well, I think this might be a nice transition point to Jason's demo, unless, Jeff, you have anything you want to add. I know it's 4 a.m, so I like to be considerate if you're
fine. I'm just
feeling sleepy.
Just being social.
Okay.
I'm waking up.
Cool. All right. Well, Jason, Nodal Spike on Twitter has a very cool demo to show off called Alpha Henge. So take it away.
Yes, so I'll go ahead and, I need to allow that. So basically, there's a couple different things I can share here. Should I just share the whole screen? I'll share the whole screen. It's fine, proprietary information, who cares? Anyways.
Also, if you could zoom in a bit for text that you need to focus on so that the recording has a nice view.
Yeah, how do I do that here?
Command plus.
Command plus. Okay. Oh, that's too much.
All right, that's probably fine.
Okay, so is this good enough or too much?
One more.
Let's try that.
All right, that's
that
good.
Feels like a lot. Anyway, so just going through the reason I built this harness is called Alpha HEng, which is Alpha Hydrogen Engineering. Originally, it started as a concept based on the Alpha Evolve paper, and basically it's just kind of LLM fuzzing. If you guys know high performance compute fuzzing, old school, basically just generate random fluctuations in code until you get a better result. So what I have created here is a harness that specifically what it is none of it is authored by me anymore because it's a self-improving harness. And what it does is it builds projects, and what you need to do is you basically combine every single subscription plan for tokens in the world that I can find, including Claude Code, including Codex, OpenAI Codex, including Minimax, all of them. And then you put them all into something I open source called CCR Router. And what it does is it uses, on my side, it doesn't do it for the public one because it's more complicated. It uses a GP, so Gaussian calculations to route to the correct router. And in this case, for example, let's see, we have a couple hundred tasks currently it's chunking through. So the reason I spent 15 trillion tokens is because I was just writing CUDA kernel, and I discovered many that are 2 to 3 times faster than Cutlass for Ampere, and then many that are 2 to 3 times faster than for Hopper by exploiting low-level SASS decomposition. What that means is basically I took the GPU code. I just looked at that happens sometimes. What happens when you run, let's say thousands of agents, and 5,000 agents, but yep, you see it's still alive. So anyways, so basically I can show you guys real quick how this works. So what we're going to do is we're going to take, for example, let's say these are all sub-modules I've built. For example, I can show you guys the int4 kernels. So I was really into int4 kernels and whatnot. So basically, they're not in this. Okay, they're in my other machine. But if I initialize this one, so I basically have, again, let me show you the infrastructure page. The infrastructure page, I have this M4 Max I'm currently on, the GPU box, which has Ampere GPUs in it, and an infrastructure box that does the all of the aggregation. But there is no ERB coordinator. Originally, when I built this, I hooked up multiple Macs together, and then I used Thunderbolt as the bridge to have them not actually talk to each other, but not trip over each other while working on the same code base. Now, the question is, how do you have hundreds of agents? You can see it's, you know what, let me put this into a new window. So if you can see, how do you have hundreds of agents and or pending tasks work on the same thing without tripping over each other? It's cycling through the different machines now. Turns out it's as easy as taking everything and then putting it into what I would call a working cache in memory, and then actually testing the code, which is novel, but it shouldn't be. As in, so what it does specifically is, for example, for CUDA kernels, it literally goes and it pulls, it tries to compile it. If it doesn't compile, it gets discarded. So it's a infinite monkeys theorem with LLMs.
So kind of the thinking here is like, anybody know the infinite monkeys theorem? Are you familiar with it? If you have a room with infinite size, you have an infinite number of typewriters, and then you have an infinite number of monkeys. Just by the laws of infinity, you're going to have one of those monkeys write Shakespeare. And so what Jason has done is he's kind of, the monkeys here are the agents, the typewriters are the, the code bases, and then the Shakespeare checker is basically the testing harness, right? So that's, he's atomized the task into test and throws infinite monkeys at them.
Exactly.
But
for example,
writing from scratch every time?
Nope, I'm never doing anything from scratch every time. So for example, let me take this. So I take, let me go ahead and try this. go ahead and take the README and then take everything else in this repository for Orchard and then make it into a large Alpine task list, at least 100 tasks, and then add it to the coordinator. So what, can I talk about Orchard?
Yeah, sure. I'll give you the brief TLDR, which is, I'll show you guys the tour later, but we're building a data center here in Kernel Labs, and it's all Mac minis. And Jason's helping me build Mac device management software using AlphaHenge. So I gave him a very lengthy prompt with all the requirements, and it's been chugging for, I think, the last 24 hours, so.
It did it in 30 minutes, but yeah, we can make it prompt ready. But yeah, this is, when you give it an easy task that doesn't have a massive cap on it, it's fine. It'll just crunch through them. So actually, let me go ahead and open up a new dashboard. So dashboard. Let's see if we can see the numbers. I might have to edit stage into my other one to see it. Can we see it from Grafana? Oh, we can. Okay, so yeah, basically, it's been crunching through. So let's see. For example, total cost $0 because of course I'm using the API plans. This is a success rate and then observation, success rate, Thompson mean, all of these different, you can see when I stop. I basically never stop hyper engineering. I'm always putting through tokens. So hourly completions, you can see last 24 hours. So basically, yeah, so I actually did a refactoring. This is why this went down so much, but now you can see now it's going way up. So let's go ahead and do the last 30 minutes. Last 30 minutes has completed 159 tasks, 660 pending, 18 in progress. These are either quad code or codex instances, and wow, GPT OSS is doing great. So is Wafer. Wafer, shout out to Wafer. I'm hoping they succeed because I really want to have unlimited everything because I can burn through. Don't worry about that. That's me just trying to snipe GPUs. Anyways, so this is now 31% of the way through. And yeah, so to get diverse outputs, this is very important. So to get diverse outputs, what I do is I use the Thompson plus the GP model that is constantly being trained by every output. So I give the Thompson router and then the GP router the prompt plus information. So let's say I want a massively exploratory CUDA kernel, right? Then in that case, it did something like, what if we decompose, don't steal this, Undergrid. You can write it if you want. How do you make a PTX kernel that doesn't get absolutely smashed by the compiler if you try to go from int4 to FP8 for Hopper? And it did it because it knew which one to do.
So for context here, with the Thompson sampling, for those who are not stats nerds, instead of infinite monkeys where you just like do equal allocations of each model, it intelligently selects what proportion of each model would be appropriate for the best task, right?
Yeah, exactly. And then it also does sorry, I forget your name in the comments, but you said specifically, yes, it also does modulate temperature and then modulates also the thinking amount based on what we've learned. So it's something like if you want to do something static, like make a production ready thing like Orchard, then that's how you do it. This is how I wrote a driver for many different devices that should not have drivers. For example, I could do a party trick right now where I put a 3090 onto my Mac, and that shouldn't work, but it works because I don't need to spend human hours building things. I can just put a wish list down, and then eventually with infinite LLM monkeys and infinite compilation time, who cares?
So where do you specify the features of Orchard, for example?
So specifically, initially, Alex gave me a list of just what he wanted. And since then, it's built out the front end, docs deployment, Alvanic. All of this is not handwritten in the slightest. API billing, docs, MDM provisioning, SDK. All of this is not handwritten. And it's actually good code because it must be. Otherwise, it cannot survive the shredder. Which is the other part.
So how do two pieces of code compete?
One more time, sorry.
So like if it wrote the assignment bootstrap twice, like how does it choose which one is better? Just like
so it's pretty simple. So it tests it against a rubric, which is it PEP 8 compliant? Is it Pythonic, which is obviously totally up to you, but also which one is shorter but the same functionality once you run it through the test harness.
Cool.
That's it.
Nice.
I mean, it makes it so the code bases don't sprawl on purpose.
Can we see like or the
if you run hundreds of agents, you generally won't get like stuff like this or Docker file and all that. And I made a software bill of materials because of course it did. It just does things, and it's like, okay, well, how much? That's really fun. I didn't know it made a software bill of materials for visioning runbook. So yeah, it writes a lot of documentation, which makes sense. A lot of documentation, it survived, and there's an index for all the documentation as well. So it's not just, oh no, we have a ton of documentation. But yeah,
that's awesome. It looks like really nice quality. But how do you Can you show us front end or like any test suite or anything?
So specifically, for example, I can show you what is interesting in here that I can show very quickly. TAC void. So TAC void specifically, what it is I'm using the Netflix void model, which if you guys don't know, let's go ahead and take a look at this. What it does is it removes
what does it remove?
It removes images or let's see, void model. There we go. So it removes objects from clips.
For movies, okay, cool.
Yeah, exactly. So now I took the entirety of Empire Strikes Back, and I'm currently running it through Void to remove Luke Skywalker from Empire Strikes Back.
Okay, that's cool.
And how that works is basically it just works, and then it's also building a new model. Let's see what else we have. The Minecraft sim, not initialized.
Like, do you have did the video render yet of the Empire Strikes?
Well, the video rendered, but right now it's in quad mask form, so it's not really viewable. It needs to be crushed, so it's currently crushing it together. But for example, this is a new reinforcement learning tool that I built specifically. What it does is it uses Oracle distillation plus multi-judge, and then it also has all the different pieces that for GSPO and whatnot. Now, let's see what I can actually show that's actually visible. So everything in Contrib, let's see. Oh, eBay deals, there we go. So we can actually run this. So.
Okay, this is like some sort of drop shipping app.
No. This is actually for us to obtain as many Mac Minis as possible and also find, go ahead and launch the eBay deals UI.
That's cool. And so,
also, by the way, this only works for some reason. I have tried Cursor, and specifically, I have a piece of documentation about why this kit doesn't work in Cursor, because Cursor doesn't have tools like everything, the extensions, all of the pieces in there. They're not the same, and subsequently, I'm not saying it's impossible to replicate, but Claude Code falls in its space, Cursor falls in its space. Everything I know else otherwise falls in its space. So.
Jason, that is a fantastic, interesting observation. I wrote about it about 4 years ago. I was working in the company Gitpod. We made OpenVSX and a few things. Microsoft actually started motions of lawsuits over how we do things with VS Code. And then Cursor themselves fell into the same traps that we did. Essentially, VS Code is a closed ecosystem, and as soon as you compile your own version from the source code, the entire ecosystem fractures. It's really interesting. The executive who was behind some of that strategy departed Microsoft yesterday.
Wow.
So here is.
I'll drop the link for people who want some archival things. But yes,
yeah, that'd be really interesting for sure.
It's a real issue.
So here's something that I just told it: find eBay deals that have the greatest upside through scraping and through different pieces. And
know the upside
this is
from other deals on eBay? How does it know the upside from other deals?
So, for example, right? Let me show you. Let me try.
How long did it take you to write this? You just told the prompt.
Around a couple. I mean, for me to actually write it, I sat down and I just hit my dictate key and I asked it for a app to find the best eBay deals.
For certain types of hardware, or just period?
Period. And then, so let me try Mac.
You have a list full of hardware here, so how did you get that?
Oh, this was scraped through Gina, the AI.
Okay.
Yeah, so let's see. We have... Don't worry about it. Everything constantly just breaks here.
These are all the eBay listings across eBay that have the website, or are you looking in a specific category?
So I'm looking at some specific ones. Specifically, so this one's the 178. So this one is a U.3 drive. So that's why it makes sense. So why? So I have median and mean. So sold average and median. So this one is a 30. So pretty massive upside if you have a U.3 to M. So to PCIe adapter.
So you're buying it for $200. It's worth like $440.
Yeah, exactly. And this is how I start acquiring hardware. Like, for example, let me go ahead and grab my hyper engineering stack here.
Oh.
This is around, I don't know.
Wait, you're still sharing your screen, so we can't see you holding the GPUs.
Never mind. Okay. I probably look like a crazy person right now then, huh? Okay, let me see. 1 second. How do you work this Zoom thing?
Just stop sharing screen.
Yeah. Okay, so this is how I get these for $25 a piece when they were 8K retail and they're still perfectly good for compute. In fact, they're actually what's running on my inference. So, for example, this one is 16 gigabytes of HBM2 memory, and I power the limit in 225 watts, use millivis to do vector DB, and then it just is the fastest retrieval you can imagine, and it's all local.
So let's go back to Alpha Evolve though, and Alpha Henge. So
Yeah.
when you give a task, right? How does it refine? So it was really beautiful, like the output, like it's actually building like a real app, very tastefully. Sure, maybe the front end design is a separate thing, but that's just like a little skin on like what's already very beautiful. The bones are really good, the code looks really good, the thinking is good, the docs are great. So how does it know to refine towards your prompt rather than sprawl?
Yeah. So basically, it's because I ruthlessly root out anything that can be considered edge case, in the sense that everything is held in memory. This is why you need machines with massive shared memory. Let me put down this stack of GPUs and then share my screen again.
Everything. It's opening up new work trees with the whole app, doing a bunch of code changes in parallel, and then selecting the best of those code changes generationally. Am I right?
Yes, but the thing is that it's only a couple bytes per. Yeah, for example, it's like the 3090 and my eGPU dock that technically neither side supports it, but I'm gonna go and share my screen again, and then you guys can see. So I can show you from here. This is actually this is the most important part.
And how you're picking, I fully understand how you're picking the different models, but I didn't understand the proportion.
Yeah, exactly. Let me show you how that works functionally here. So, there we go. Share this. Okay, so you see this, right? So first pass is ignore. First pass is it has to pass a linter if it's trying to touch anything that's like, Rust and or Python and or C++, whatnot. So, and then specifically, we have we have each individual piece here. So it's crunching through them at a pretty decent rate. So that's what, 30 taps per minute for one, which is, I don't know which machine that is, but currently running it over 2.
Is there is there like a layer creating the tasks? Like, is there like
so it's actually using 0MQ. So the layer creating the task is actually VS Code Insiders, which is the crazy part, is that this is creating the task. And if you can see, it just keeps going and it keeps making them.
Semantically, where are the tasks coming from? Like an LLM has to be coming up with the next wave of tasks.
Yeah, yeah. So it's doing it specifically with VS Code plus Copilot. Copilot is required because Copilot, what it does, you can see if you're in the debug view, is it injects this inside of the system prompt. If you ever had your agent ignore your agent's MD or inside of your...
We're just looking at Alpha Hinge, so I don't know what this is.
Yeah, so I'll just basically go ahead and edit this. So what this is it's basically a list of tools, what it does, and then exactly what you need to do to make a perfect task list every time. That way I never have to check.
I don't know what you're showing me.
Wait, you're only sharing the terminal screen if you're.
Oh, my bad. Let me.
Yeah, we
my bad.
Perfect task list. Because that one is a good start. Before you start multiplexing like the different attempts that are like atomic and selecting from them, like where is the next task coming from, right? So if the task is like build me a new Mac orchestrator, right? There has to be like some sort of plan. Right? So are you doing a planning step, or is it just
no planning? Planning usually hurts the final result.
So let's say you start with something high level, like just like that, like here's like some details, some functions I want, some kind of app, and just for the sake of argument, because we just did Orchard, like it's like let's orchestrate 500 Mac Minis in a room that are bridged like this, right? And build a front end on. So now where's the first round of tasks going to come from?
Literally from AlphaHenge with GitHub Copilot. That's the only thing it does. Okay. So it must be using Copilot, otherwise you must build your own harness that injects specific tool calling, uses the extensions as a linter, etc., etc. You can see all these different things it can do.
VS Code API to
yes, exactly.
Snapshot the state of this new project.
Yeah, and then that's why the linting is so fast. It's because it could be like boom, 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 boom. Otherwise, this wouldn't work.
Kudos for doing that. That's a nice piece of orchestration there.
I guess I just always loved Insider, and I was like, wait a second, I can just do that. So
you just have one Insider's build though with an empty project right now, right? And then a spec, which is like maybe 20 lines. So
the spec for example, Alex, how long do you think the spec you gave me was?
It was 1,200 lines. I spent a lot of time yapping with ChatGPT to write a good product spec.
Yeah, you don't need to get anything close to like a very specific thing. Literally, this is me just literally asking. Yeah. This is not a plan. This is me saying, hey, I noticed that this seller has has mispriced eBay listing. Yeah. And then I said, when ChatGPT, give me a markdown document that make use of this arbitrage. And then he gave me this.
Fine. Okay, cool.
So that's not the planning step that usually people think, right? The planning is usually this.
Sure, this is literally just with an LLM, and you.
Yeah, exactly. It's just you literally dictate your brain to dictate your ideas to an LLM. It'll spit out a markdown document, feed it into AlphaHenge, and then it should.
A lightweight spec, right? And no project, and a VS Code Insider's build that spins up with this lightweight spec and no project. So now which LLM Copilot in the VS Code Insider's build is the one that comes up with the task list for what to do next, right?
Yeah, and it doesn't matter which one you use. You can use Opus, you can use Auto, you can use Son. It doesn't matter which one you use because it's so.
By hand, right? This is being orchestrated for you.
If you notice, I'm pretty hands off on it building things right now. So this is why I can work multiple different projects one time.
It spins up the task list. It puts the task list into a Markdown doc, or like VS Code has a tasks API. I don't know. I don't really use VS Code much anymore, so I have no idea what Copilot does. So where does
Copilot Insiders has a lot of very interesting features. Autopilot Preview, what it does, instead of how Cursor does the autopilot, where it just keeps going, it literally asks the model itself for example, if there's like a question in here, right? It's like, do you want pseudo? Actually, you know what? Who cares about pseudo? We're just gonna go and do it. So the model will then go and answer it. So let's go ahead and actually pop this out into a new view. So
it's
let me make sure.
Like type of thing going on.
It's actually a data flow machine, if you know what those are.
No.
So
yeah.
A data flow programming style basically is what I based this off of. So.
Okay, so it'll come up with like the initial task, like, oh hey, this is what I should do next if this is the plan.
And exactly, and then
you'll have this variety of LLMs with different settings all tackle the same thing.
Yep.
Okay.
And then, for example, this is going to spin up 500 agents on this machine. Now, a Mac with 128 gigabytes can't handle that.
Yeah.
It's the reason why is because the only thing that nothing is actually talking to each other. That's the crazy part here is that
how many times you're getting the same solution from different LLMs by chance?
Almost never actually. So I have this inside of this data. You can see 218 tasks. In the past 30 minutes that we've been talking, I've completed another 100 tasks. So.
Okay.
Yep.
Each task you spin up how many from the pool?
I just spin up whatever I vibe like today. I'm like, do I want to push the limits with 500? Oh, 0 tier is also important if you're doing multiple machines because that way you can have less than 1 millisecond latency between each machine with 0 MQ.
Okay. Yeah. To pass the messages. So 0 MQ is passing the whole next commit or batch or whatever?
No. So 0 MQ is only passing whether it succeeded or failed.
Or not. Okay.
Yep.
And then how do you do the evaluation pass?
So the evaluation itself is done by the linters inside of VS Code Insiders. I have written extensions, and there are existing extensions that just boom, 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 fail, retry,
Okay.
and then complete. That's it. That's all it is. It's a ruthless shredder. If you're over 1,000, if you're over 800 lines of code, disqualified. You're not allowed to have that.
Yeah.
All right, guys. I'm gonna get AI psychosis unless we take a breather. No, Jason. Jason. This was awesome.
Honestly.
Super
I
awesome.
finally understood the evolution. I was like, oh, like I've been.
Aditya's like he's reviewing the thesis. You're reviewing the dissertation. He's like their committee here.
Yeah, I got myself. Where's the evolution? I finally got it.
I think maybe well let's anybody else in the room kind of blown away and have some questions.
Yeah,
Okay.
Yeah.
I guess
That'd be great.
my question is just like I'm curious where you're getting like all the tokens or like how much is this like running locally. I mean, as an example, like you were running a Void model, right? That's like a video model. Do you have like an A100 you just have at home or you're running that on or what?
Well, so I have this in my cabinet next to me. 2 3090s in my IKEA drawer, plus a third of a Pro. So maybe that helps to understand a little bit. I don't know. It's just how I work. I have a whole bunch of compute, but the thing is that don't use it for actual generation unless there's no API serving it. Buy the coding plans. I keep yelling at people in the chat to buy the coding plans because they give you so many tokens, and I have an infinite token glitch now with the ZAI, where they're literally, I use trillions of GLM 5.1, and it performs better than Opus, Opus 4.5 definitely, Sonnet 4.6 high.
The Chinese gray market token plans, for what it's worth. So Minimax, ZAI, what's the other one?
Kimi is actually really good, and Minimax specifically is the best plan. I found out why. 512 concurrent requests. I check their headers. I log everything. So all the incoming and outgoing traffic I log. And I noticed, wait, why do I have so many things completed by Minimax? In fact, let me go to the graph on the dashboard. GPT OSS makes sense as well because why not, right? Might as well do it off DigitalOcean credits. It's easy to get a couple thousand. Wafer's doing great. That's kind of surprising to me. But yeah.
So yeah. The token plans are dirt cheap. You can get like near unlimited token usage for like $80 a month on GLM, right? So the max plan. So I have a wait before any of you guys actually buy it. I have a discount code, and also understand that if you don't have auto subscribe on, you're gonna have certain penalties and also pieces like that. I'll write up a quick guide for you guys, or Alpha Henge will write up a guide for you guys to basically, for under $1,000, extract tens of millions, based on my math, of dollars of tokens a month. Especially if you do stuff like have 500 agents running on my 34 Pro, testing CUDA kernels for 3 days straight, which is what I did. Nice.
So one thing I was kind of wondering, with the self-improving harness, have you looked at what sorts of like skills and tools it's created for itself that are really helpful?
Here's the interesting thing. It doesn't do that. In fact, I prevent it from using skills or tools. Now, tool calling is different in the sense that it's allowed to do what we call a tool call nowadays, but it's not allowed to use MCPs. It's not allowed to use anything else other than something I open source called CCR Rust. Now, what CCR Rust does is it does the load balancing, but also it does token saving. There is 3 different levels, which is 0, which is no off pass through. Then it is medium, which is it saves 40 to 60% tokens depending on API. And then there's max, which is 70% plus tokens. So how it does it is, for example, your creating harness may not actually need, especially if it is a Chinese model, I'll put the link to CCR Rust. I open sourced it very recently again because I was confident it actually works for everybody now. It's also specifically set up so if you put Claude code or codecs into it, it'll just set it up properly. There's also a single line of code guard inside of it as well. By the way, my MacBook, while I'm streaming this, is running 256 instances of Claude code. Yeah.
How many times a day do you get the Python error?
I don't know how to disable it actually. Every time, I don't know. I just ignore it. It's muscle memory at this point.
That's why Jeff is rewriting the OS. It's only to remove the Python warning.
I did actually modify the OS heavily, so that way I could do CUDA on Python. For example, let me show you this really cool thing. So go to System Settings. So I wrote a CUDA driver for macOS, which sounds insane, except for the fact that it's not impossible, obviously, because it's only
insane. It's not insane.
Not actually crazy. I mean, one day you can do heterogeneous compute. Can you see this?
Yeah, we can see.
Well, yeah. So currently I don't have any GPU plugged in, but yep. It's just CUDA on my normal macOS. Now you must have the beta actually, because there is the RDMA, right? So that's just what makes it viable. Yeah, and
Jeff
I ran the RTX and the Pro Blackwell.
Jeff is just losing it in the corner over there.
What do I have?
Nothing. Don't worry about it.
Okay.
It's not insane. It's just a preview of what normal is, and I'm not happy.
Yeah. Wait, you're not happy?
No, I'm saying it's a preview. It seems insane to other people. It would seem insane. Mm-hmm. It's an advanced preview of the future.
Yeah.
I appreciate it. That's a great compliment.
It's outside the Overton window of acceptability.
Yeah. And that's so yeah, for example, this is, in fact, let me open up Mactop and you can see. Really? I know. Anyways. Oh, they may not like this. May not like this at all. Okay, so yeah, we're pinned. Look at all these Claude code instances running. In fact, some of them upgraded made run. So it's just spinning them up as fast as it can possibly handle, and this is why I have this much memory on this machine. Because otherwise, it wouldn't work.
Just use more machines? Like, can you put
where can you get more Mac Minis?
The Apple Cloud, yes.
Just come here.
So here's the problem, is that I tried this on the Threadripper Pro, but the problem here is that unified memory, I'm abusing so many of the zero copy features of unified memory that it makes it so that this is very viable, whereas if I was to run it on, for example, this one, it has to do things to deal with the NUMA nodes and whatnot. And this is the problem where, when I look for CPU options online, I found basically the cheapest is still untenable compared to just literally buying more Macs. That's it. Yeah, you can see I have RDMA on, so that way I can always use that. But yep, so this is currently, it's currently crunching through a couple hundred tasks I just gave it. Oh yeah, you can see there's file placement violations also. So if it tries to put something in the wrong spot, it goes like, nope, killing it. Yeah.
Sweet. And anybody else
got
questions, or your mind's too blown?
I mean, I'm willing to share details on how, like, the architecture is basically linters plus static checks that are cheap equals you can write anything you can dictate. Like, any idea you can dictate. I have yet to come up with something I can't do, which is interesting.
No, Jason, that's exactly it. Like, I don't know what to build anymore because I've proven that anything can be built. So it comes into a moment of just thinking what should be built because you know anything can.
Yeah.
You can express it.
So, I especially agree. And one of the things is that one of the great parts about AlphaHenge is that these two things are not mutually exclusive. As in, I could throw, for example, I have an Optane KV cache pool, which is basically I use Optane memory as KV cache. This is old school DDR dynamics, but I literally graphed in Mooncake and VLLM and what you call it again, K transformers together into one literal blob of a serving infrastructure, and it beats everything else on the market for my specific use case, which I can then tune it for everybody else's use case without bench. So it's one of these things where I literally said, pool these 3 repositories together, take the best parts of each of them and put them into one new serving harness, and it works. You must use VS Code though. It's really sounds insane. Like, it sounds like I'm making it up, but I've tried everything else, and it must be the insider's variant. Otherwise, the agents have drift off course. They don't know what to do. They try to modify things you're not allowed to modify, etc., etc. This is allowed to flash VBIOSes, whatever, because I'm very confident in its ability. This is how I made it work specifically with the Threader Pro. That's why this 3090 is not plugged in, because it's flashed for Mac OS VBIOS. So, like, what else am I going to do?
Jason, this is so obscene. I can connect you to some folks at Hub if you don't have the connections. I might be able to get you comped on Copilot.
If you want to, yeah, of course. I mean, for me, it's just like, yeah. I basically barely use up on my Copilot because all I do is I just hit dictate and it gives it the idea, and then AlphaHenge actually builds it. And I can also plug in GLM 5.1 to Copilot, and then it works.
Cool.
It's just in your GitHub settings, by the way, to add third-party models.
Hey folks, something I've been thinking about. Are the programming languages we have today going to be enough to carry us into the future? Because I've been thinking, like, if we want to build these AlphaHenges and dark factories and software factories, that perhaps if we were, say, to build it in Python, Python won't handle the load-bearing weight of like a software factory, like just an easy one, like the soundness of programming languages. And I've been exploring all the damn languages, all of them, looking at concurrency and OTP primitives from Erlang, playing around going back to OCaml, switching back to Haskell, playing around with Rust. I'm not sure. I'm wondering if there's going to be like an alien space programming language come into existence from an AlphaHenge. Because it'd be really easy to bootstrap it. Figure out how to get LLM to program.
Aditya, do you see the language up there?
You're gonna
I have a thesis, actually. Yeah. So I have a thesis statement on this. So everything that AlphaHenge can do and can be easily checked can be done in exactly 4 languages. One is Objective-C. The second one is Carbon. Have you tried Carbon? No? You must look up Carbon. It's so good. It's one of the best in my opinion. I've made Carbon work so much for production, but it's so good. It's basically, and then Rust, and then Python. That's all we need, because once you start training models from a pre-training perspective, if you only have those 4 languages, there's nothing you can't do with those 4 languages in the modern compute world. Carbon, by the way, for people who don't know, is Google's attempt to make a C/C++, not replacement, but just straight up can also be C and C++, but also has Triton-like dev tools. So it's like Rust, where Rust has the borrow checker. That's why it can do things so quickly in Rust. But Carbon is faster, but it does not have as many safety features built in. And Carbon can run on anything basically too, because anything can run C or C++.
That's what I've been playing with, because the way I look at it is we've got two stages. We've got a generate stage and a check stage.
Mm-hmm.
And if the programming, we know LLMs hallucinate, whatever, they generate bad things. And if the check phase takes too long, then it punishes the generate phase.
Mm-hmm.
So that means if your compilations are too slow, so it's finding the right balance between having the right level of inbuilt check within the application.
Yeah.
Or doing similar what you've done, or apply statistics over like, say, is it PEP8 compliant type topics.
Exactly. There's auto PEP8 from Python. It's just like, okay, instantly yes or no, or if it is or isn't. And then hallucination is actually good for me because it'll hallucinate things that I've never thought of. For example, the int4 to FP8 kernel decomposition means that you can store weights at 4 bits per weight, but have the dynamic range of FP8. Never thought about that, but it's 2 times faster than FP8 is now. So, I think I'm going to have one of the fastest FP8 kernels ever. Whew.
Has anyone been keeping up to date what Dropbox is doing internally in the AI applied lab?
What are they doing?
Keep an eye out for something called DMath. It's not open yet, but they're starting to tweet about it. Essentially, they've been running model checkers to rebuild model checkers. So they're taking Lean, Coq, and all the feature improvers and rewriting them to Rust. And that way they can inline model checking into their actual application. They'll be releasing it soon. It's pretty cooked. It's very interesting.
Yeah, I saw you tweeted the post there. I should join the Zoom to post the link.
Cool. All right. So, any more Alpha Henge questions, or our minds are sufficiently full of information now? All right.
I was wondering if like you could use Alpha Henge to like formally verify like big parts of OpenClaw.
What? Sorry, one more time?
Like formally verify like big parts of OpenClaw, like exec and.
Yes, absolutely, easily.
Yeah,
That's one of the
cool
things where for example, I literally found a massive bug in how VLLM was inferencing GLM 5.1, which is probably why a lot of them are bad right now. And I submitted a PR today using Alpha Henge because I was like, why is everybody else's quality so low? Turns out they're not doing per expert calibration. Everything's just being treated like a dense model with big MOE. So I didn't know that before going in. I went like, Alpha Henge, figure out the problem, and it figured it out.
Try that probably. I think it up.
Cool. All right. Well, big round of applause for Jason. Thank you for the very cool demo. All right. It is now 7:32 p.m. We got started around 6:30. We only did 2 demos, but if anybody would like to show anything real quick, rapid fire, anybody in the room want to do a cast? All right. No one. All right. No competition. Anybody on Zoom want to do a cast? I see Patrick, Ian, Jeff. I know it's 4 a.m, but otherwise, I have a demo. It's a quick one.
Let's go. Come on, man.
Yeah. Cool. So let me see if I can get this working. All right. So jumped on the claw train a little while ago. And I've become very interested in evidence-based medicine. No, evidence-based task review, right? So a big challenge with a lot of these things, and Aditya, we're kind of getting at the heart of it, which is they produce a lot of slop, right? And you can see the code, but you don't know if it actually verifies the code here. So there's kind of two components here. So number one, I tried OpenClaw and I tried Hermes, and I wasn't like super satisfied. So now what I do is I built kind of my own harness, and it's kind of like it's kind of like a technical product manager. It's smart, it can write code, but it isn't really like as sophisticated as AlphaHenge, or like some of these like really stable harnesses. So let me see here. I can just give it links, and it has its own computer to do work for me. So let me find. Okay, yeah, great. So here's a really good example. I found this tweet that was like Mistral just dropped this new open source text to speech model from 11, and that beats 11 Labs. 3 gigs of RAM. Very impressed. And so I tweet at Crawley, try running this model locally, record some clips, and save them. Benchmark how long the various samples take. And what it does is it cooks for a while. So I prompted this at 12:21 a.m. and it kind of gave a final response at 1:51 a.m. So not fast by any means. But what it does is it's very evidence heavy. And it very specifically, like, it has these review steps that says, if you're going to go to the next gate, there's multiple gates, you have to provide like a sufficient evidence report. And then ultimately, it's going to produce a video that you send to the end user who asked the question that answers the question or demonstrates what's going on. So I'm going to try to... so this is a video that it entirely made by itself with Remotion. There's some glitchiness with the CSS, but it's to be expected. But it kind of gives me a briefing, right? Kind of like an executive briefing. Okay, that sounds horrible. Believe me, it's actually, you can hear it actually making the audio samples. It goes to the video. Hold on, there we go. Goes to the video, where's the stuff? It does like different samples and long sample, short sample, and then it makes like a benchmark table. So what it's done is like I've taken this high level question and then it asks all of like kind of like what are the details that an executive who asked this question would be interested in. I think it's a little bit too verbose with like some of the technical details here, but the fact is that I was actually able to run an end-to-end like simulation of it on itself. So how do I do that, right? Like it's not on a VM. Well, it kind of is. I've been using Hyperbox here. So this is where the Mac Mini cluster data center I've been building comes into play here. Everything is running on a Mac Mini. So I have a Mac Mini in a stable location. As you can see here, this is like me screencasting the remote Mac Mini. I'm using a program called RustDesk, which is like super fast. And then this is kind of like the arbitrage port. So I have a TUI here, and it has full access to the computer, basically root access. As root access, it can use browsers. So it uses the browser plus this really great extension called Playwriter, which lets it take full control of the browser. And it also has access to a Kanban board. So kind of similar to what Aditya has going, you have 4 gates. You have review, backlog, blocked, and in progress. And every time you ask it a question on Slack, it moves something to review, right? So, another question I asked it earlier, like kind of similar on the eBay hunt, was look through sites on the web like eBay, Amazon, wholesalers, new shops, Shopify, whatever, and then find some cheap Mac Minis, and then it produces a report for me. And the report can either be a video, it can be a markdown document with links, and it can even like push back on me. Because like, for example, I misspecified, and then it told me like, oh, you're not going to be able to find Mac Minis in the price range you're looking for. So anyway, that's, it's not, I wouldn't say like the most sophisticated thing, but what I think a lot of value in this thing is like you move the needle a lot less away from kind of the code generation itself and a lot more towards like what does a human take away from the prompt. And I think the models are sufficiently good at Remotion and Manim, like the 3 blue 1 brown video. They can have like make these like little videos like saying, hey, here's what I did today. It's like you have like a daily stand-up basically for your agents. And I thought that was like kind of cool, and I've been getting some mileage out of it. So that's my 5-minute demo. Yeah.
Nice.
Yeah. Thank you.
Do you read like the full output that it puts out?
Yeah. Usually, so this is one challenge with the system is I don't trust it. because it still has a big slippage. I've not been able to get around that, and I've spent maybe like a week trying to like add the review gates in such a way that's like trying to de-slop it, make it minimal, like kind of only necessary parts. And I think it's just because the way I've been doing it, and Jason kind of opened my eyes to it, is it's very much a long single-threaded process that's extremely persistent. So, you know, it kind of takes like these the Ralph principles, right? It's like keep trying over and over and over again. But it kind of has like a way that like it just always heartbeats itself back into action. And the way that it's actually built is based on the spec from OpenAI, AI Symphony. So I saw these guys tweet about Symphony. I'm going to share my screen real quick. Unfortunately, I must admit, I think this is slopware, what OpenAI published. But because they're OpenAI, I took a gander anyway. And the idea here is like they took the Kanban board to linear, right? So this is all linear, and the whole idea is they've built a spec file, and they just suggest like give the spec file to your agent, and just like let your agent build the thing in whatever your language or your choice is. And if you don't like that, they have an Elixir app. And so Elixir, which I've never used in my life before, is basically kind of like this language that's really good for handling messages. So like messages don't drop. It's like there's a kind of persistence layers inside. And so every time like a ticket moves from in progress to review, the system has awareness of that. And every time an issue is stuck in progress, you actually have a heartbeat that continuously checks like, hey, are you alive? Please work if you're not alive. And that's how I have the whole thing set up. So this is kind of the claw harness that I built myself. I've been getting some mileage out of it. Very expensive, I'd say. And that's why also I'm now, I think this is the decade of China. Like, man, these models you're getting a lot of mileage out of them. And yeah, I recommend it. Just GLM, whatever, Minimax.
Did you guys
good stuff.
try like the Minimax fast variants yet? No. Okay, let me know when you do. I was gonna sign up a plan.
So
yeah,
the Minimax Max one, only if you care about your actual like having double the TPS. For if you're running many parallel tasks, either you have not enough mental bandwidth to handle that, in my opinion, or you should just run 20 parallel tasks or 20 sub-agents and have it be 50 TPS, which paying for max doesn't make sense, or paying for the fast variant doesn't make sense for me. I would just rather throw more agents at the same plan,
yeah
512 concurrencies.
Yeah, just the quality. No, I was thinking fine for my code.
You should, but you get the normal one. The Ultra one, if it comes back on sale, I would say get it, even though it's the fast one, because it just has way more limits. Yeah. But it's sold out, so what can you do?
So Alex, what are you building the Mac Mini Cloud for? I mean, it sounds really lucrative in many ways, but like, what are you thinking?
I'm actually Jeff's point, which is like struggling of things to make, right? I think that kind of hardware is the new obvious bottleneck, and we're going to need orders of magnitude more compute, but also just hosting. And frankly, I struggled, so I spent kind of like most of the winter holidays traveling. I was in Southeast Asia, Laos, highly recommended. I think maybe my favorite travel journey in a long time. But Laos does not have stable internet, right? And I'll be at my hotel and I try to Claude code something, and then the hotel Wi-Fi is like 1G. So it would just be so nice, right? If I had like the always-on computer at home that could just run the computations for me, right? I could use something on my phone or whatever to connect to it. And they just don't exist, right? Like the VPS is like, I don't live in Shell. I'm sorry, like my brain is not wired for TMUX. I am wired for GUIs, like I think most of the humanity. So that led me to realize like, okay, yeah, you probably want a Mac Mini at home that's running 24/7. I wrote a short Twitter article about that. It got a fair bit of acclaim. And now I have a little data center running in the office here. So I'll give you all a tour sometime. I spent a lot of money on Macs, and they all sold out. So I think it's financing itself.
That makes sense. Yeah.
I mean, zero copy is ridiculous. Sorry, I interrupted.
And Jason has other thoughts about what the Macs could be used for, but I'm not really quite there yet. But he's helping out with it. So.
They've got really interesting hardware properties for sure that people don't know how to use, except maybe Jason now. So that
Yeah.
Nice.
What's your thoughts on if you just have like an extra MacBook? Can you just like run that 24/7, or is that a bad idea?
No, I think it's a great idea. I think that, well, I think at its extreme limit, the Mac batteries, they tend to overheat a bit. So you might want good ventilation. I mean, even this thing, this is an M1 and it's like, it gets really hot, right? I think the Mac Minis just have like better built-in fans and cooling. Conceptually you could use an iMac too, right? But the form factor of the Mac Mini, I think, is quite ideal. And one other thing I really recommend checking out, if you want to avoid paying me money and you'd rather just have one yourself,
just come to the office and then plug into the machine and reset it. And just hijack it.
Yeah, pretty much. Actually, let me go grab it. Do I have it over there? No, I don't.
In theory, so for the MacBook problem, what I've done is I went ahead and I opened up the bottom of my MacBook, took out everything, replaced it with liquid metal for all of the thermal paste and everything, and then put it back together. And then now I'm running 100 and maxed out CPU and GPU at a cool 54C.
So you're welcome to try that too. Yeah,
Don't do that. No, don't do that. Gallium, it does not mix with aluminum. I'm just a crazy person who doesn't care if they're $10,000 Mac to create. So.
Yeah. Exactly.
So if you decide to be a crazy person like me, that works.
Awesome.
Jason, I would love if you would dump your brain in a gist about min-maxing ZAI.
Yeah, I will basically dump everything about how you can min-max not just ZAI, but every...
Don't tweet it, but just...
Just let us
it's
know.
funny because they're catching on, though. Is the thing that they're catching on. The limits are going lower and lower. Everybody is realizing the economics of serving these unlimited plans are like, wait, somebody's going to sit there and fuzz CUDA kernels for hours and hours and hours, and we can't sustain that. So, yep.
Cool.
Yeah, no, I'll dump into a gist or something like that for sure for you guys.
So I'll add a little closing note. I'm sorry, Nikhil and Sarav. I know it's like super early in India if you're logging in from there, but the kind of closing note is, I think for the folks who are on the hyper engineering side, it's a challenge for us now. The VC subsidy is starting to disappear, right? People are, well, if you're creative, no, but people are starting to wake up that like you can really spend a lot of tokens. And you don't even have to be that productive, right? People are just kind of like doing their normal work, but spending a lot more tokens doing that. And previously,
I'm in San Francisco actually, but this last point, what you said, that really speaks to me because I have, I'm kind of scared actually that I am completely powerless without my agents. I am doing everything through them. And I don't know if I can do anything by myself manually anymore, right? I don't know if I'm spending unhealthy amount of time and effort to make stuff work through agents, but I think that's kind of the learned habit now. And my expectation is that, okay, it removes all the friction away, and who cares about the tokens, right?
Yeah. So what I would say, specifically, if you're worried about that, is the Alpha Henge philosophy or my philosophy has always been, I could just literally run GPT OSS 20B on my local machine and it would work. I don't need anybody else's API model, whatever. Who cares, right? All the models out there run 20B with VLLM with the amount of compute I have here. With offloaded KV cache, that's around 1,000 concurrency. Yeah, it'll take longer, but who cares? It'll still get done. And every time you run it, it'll improve itself.
Really though, I have tried open code. I have tried, all sorts of, from LFM. Now Gemma 4 has got people's attention. But, it's Claude code and
I would say OpenCloud very specifically has, OpenCode is gimped by a lot of providers. And the reason why is because they had some legal issues with a lot of providers with them intercepting OAuth keys. And so specifically, OpenCode still passes headers over. So, for example, when I gave Alex the the keys to the kingdom with how to get GLM and do whatever, he realized that he was limited to one concurrency at a time until you spoofed that you're not using OpenCode. So you should probably, what I do is I take Codex and/or Claude Code and I modify it using AlphaHenge to strip out everything that I don't need, including MCPs. I think MCPs are terrible and should not be used. I'm going to be honest. I don't like them. They are a waste of tokens and they don't do anything useful. I am like, why do I want an MCP when everything can be run within milliseconds or microseconds with a linter? And I'm just like, I don't need any of this.
Yeah, but still, I think how we need to have browser use and computer use because the rest of the world hasn't caught up. I think MCP is still that stopgap where the rest of the
Absolutely.
world will
Yeah, for normal people, for sure. Yeah. I 100% agree.
I wish, everything becomes CLI again and no MCPs needed, just some progressive disclosure, small blurbs in the system prompt and boom.
Yeah, actually, if you take a look at what Codex released, OpenAI released recently as a Codex plugin for specifically Claude Code, if you take apart the code base, you'll find they're using some very interesting token saving tricks. I actually implemented them into CCR Rust. So there's 3 different tricks they're using that basically compress tokens in a way that's lossless that I've never seen before. And I don't think anybody else has actually looked into it as much, but I just pointed AlphaHenge at it. I was like, take the best things from this and put it into my harness. And it just did it. And I'm saving around 40 to 60% tokens, subsequently doubling my capacity.
All right, I'm going to be digging that code base after this call. What's the 3 tricks so I keep an eye out for them?
If you just use CCR Rust, I have them built in. So if you wanted to, it's Cloud Code Router Rust, or yeah. So I went ahead and extracted them for you. They should be in a docs file inside of that.
Yeah, sweet. I've pulled it down.
Yep, it's if you just get any agent to build it, it'll just build it correctly because I wrote the agents MD. By the way, a small trick. I don't know if anybody else does this. Does anybody else symlink their agents.md to Claude.md?
Yeah, every repo.
Yeah, I was like, I used to use Gemini.md, but then I realized Gemini CLI has no good use case because it launches too slowly.
So there is one use case for Gemini CLI. I use it as a reviewer. So I have Claude Code. I initially built a skill for Claude Code to invoke Gemini CLI. But I then realized I don't need any skill or anything. I can just ask Claude to use Gemini as a backup reviewer. You can just do Gemini hyphen.
Yeah. So like to do a cleanup. So specifically, I would try switching it out for the OpenAI one because the OpenAI one actually does that very well. So that would just be a 1-to-1 swap, and they have token saving feature built into that. So you don't need to even worry about the overhead of launching an npm thing. It literally just has it built in. So yeah, I can link you guys to the OpenAI repository too. So one thing also, quick question. I honestly don't know. What do skills do?
All right, but before we answer this, before we answer this question, guys. So if you would like to leave, I know we've been in a very intense brain dump for the past hour and a half. You're welcome to head out. Otherwise, I'll keep the room on because I think we're having a pretty good discussion. But I just want to thank everybody again for pulling up. It's been a blast. I've learned a lot as always. We do have a Twitter group chat, the Hyper Engineers. If you'd like entry, just send me a note and come prepared with your bills. And then you'll learn the deep secrets of Jason and the Chinese gray market models. And there's a lot of other folks in there too, right? And I think kind of like my takeaway is this. I think kind of in this world, and Jeff kind of touched on this, like, the subsidy that was kind of happening maybe 6 months ago, people are catching on to it and people are starting to consume more tokens. And we're kind of like the trailblazers here, and like, how do you identify and like really move to where the future is going? So I don't think it's like an obvious direction, and it takes a lot of collaboration and learning from each other. And that's really kind of the point of this community. It's like, just like, constantly learn new things. And, it's always great to chat with folks like this. So, yeah, thanks again.
I joined late, but I did want to, if you folks discussed it, is there a poor man's Claude Opus and Claude Code? Is there
ZAI, Z.ai.
5.1.
I'll put together a very quick guide on how to basically optimize your Cloud Code router for ZAI and for Mini Max. So that way your agent can set it up for you.
No Kimi?
Oh, Kimi, here's the problem. Kimi is priced like Western models. So there's no good reason to use it. It does so much worse, and it's priced like a Western model. So I'm like, okay, who cares? I'm just going to use a better model. I went ahead and put the the Codex plugin for Claude Code inside the chat there. That code base is really interesting. I went ahead and I extracted a lot of interesting pieces. So, yeah.
So quick question: when you say you don't use skills, do you offload things like with references to file in your assembly?
Thanks for showing up, guys. Hope you enjoyed.
Before we answer this one, let's talk about what skills are. Skills are essentially, because of how LLMs work in the context window, essentially they degrade when you go past a certain utilization. And normies were full-on blasting to themselves to a different dimension with MCPs with too many constant allocations. So Anthropic made skills, which is essentially it's a coin flip of a lazy allocation. It's really it's something that's invented to make it easier for normies not to worry about memory management. But the problem with them is it's a fucking coin flip whether they get activated or not.
Yes.
So I prefer to manually allocate a skill, or a skill just being manually malloc the markdown. When I want it to do some shit, I fucking allocate the thing that I want it to do, rather than having this fucking coin flip. But like skills, I don't know the proper background, but from my point of view, it's just something that's made available for normies, so they don't have to worry about memory management.
It's procedural knowledge which is not in the training data, right? And you don't want to stuff the whole system prompt with it, but you want small progressive disclosure. And
wrote a really good article on agents.md compression, where they showed like even if you have like a whole wiki with like a whole document tree, and you just put the index with files into the agents.md, the recall is like really high. So I really like that approach. I think skills work as long as you have like a table of contents with them in.
Yeah. For some reason, whenever my AlphaHenge thing built docs, it literally builds, like, as you said, an index that literally linked out each individual piece. I did not tell it to do that. It just does that. Yeah, I don't know why. It gave me a webinar on how to sell AlphaHenge, which is hilarious if you guys want to see that. But
I don't know how to watch it. AlphaHenge.
But specific.
I build my own now.
So basically, what it does is what I did with CCR Rust, right? Where I basically package it into you must go through this thing to otherwise you cannot get through and have this information, right?
Yeah. So recently there was on February there's a paper that dropped Skills Bench with a new benchmark for skills invocation, because this is a known problem that skills. And the Vercel blog also, very good anecdotal evidence that skill invocation, you want it to happen agentically, ideally. You don't want to have to always do / command, but it is very poor. So actually, I wrote a RL environment to train agents to pick up skills better. So yeah, there's some active work going on over there for sure. But MCP is 2025, I feel like, and skills is definitely 2026.
What's building your own Rust router? 2039.
You touched on something here, right? So this is something I've been playing with, because it's all about memory management. It is literally everything. All this is about memory management. Like the art of getting this shit good is memory management. So over in Loom, I haven't really written about this, but Loom is like 1.5 megabytes of specs. I can't allocate 1.5 megabytes of specs in a Ralph loop. I'll blow my heap. I'll just go on. But one thing I was doing is I adjusted the prompt to essentially, this is the theory. The theory is what you want to do is take some of the dark arts from the year 2008, where we used to do black hat SEO, and it's lookup tables. It is all lookup tables. So what you do is you take, I deliberately, instead of injecting all the specs, I inject the lookup table. I've got something to manufacture this lookup table. And what I'm doing is essentially linking up to the spec, giving hints to the read tool where the file or where the code exists, and this purpose. I'm gonna need to pop over a notepad to probably explain this purpose. But I found this kind of works really well. Just note here, the purpose has the kind of like a, what is it? HTML alt tag, meta. Do you remember the HTML meta tag we used to like describe for SEO, describe additional words for what a web page is in the index HTML? You can do similar here. This is what we used to do with Black Hat SEO. We used to generate end terms related and used to do keyword stuffing. You can do similar here. One tick. Let me get VS Code open and quickly show you what I mean. This is what I've been playing around with for optimization of agents.
Can I ask a quick question? So specifically,
Yeah,
I'm using specifically a tiny embedding model I trained on AlphaHenge, specifically with a entire embedded code base hosted on Millivis on Hot GPU. How would this actually be different?
I guess I'm playing with raw primitives using file system to explore on file system without going up.
Okay.
Without going up. I'm trying to do the most basic things and understand how the latent behaviors work. There's no reason why you couldn't do an embedding model.
Yeah. I mean, for me, it's like, I just love training models, so I always had some model training, so yeah.
Yeah. For the folks here, it's probably going to be really basic. So we've got a riddle.txt. Actually, no, that's not riddle. Let's go over here. I kind of see things like this. User, I want a can of Coke. User, I want a can of Coke. And then the agent then immediately goes for search. There you go, try Coke. And then I'll do can. And then it'll start doing. I kind of. When I see this as a cache miss, cache hit, cache miss, cache miss. Oh, I say I want a can of Coke. So file. It's a bottle of Pepsi. So the file contains is a bottle of Pepsi. The user prompting is want a can of Coke. And we finally get a cache hit. There is a lot of, at least on an RL or tracing eval or auto-improving agent space, to look at minimizing the bad allocations. Because the end result of this, that's a failed tool call. That could be, it could be 500 toke. And then finally, but the problem with this is this gets us into generative space. So the search tool isn't, I call it like search generative. So it starts generating end terms or a bottle or Pepsi, what else have you. It might go cap, jug, what else have you. And what I'm kind of suspecting is we want to minimize the amount of time in the generative space, because the probabilistic generative space is where it turns into an absolute shitfest, where it's unpredictable on how it works. And the more that we can minimize the allocations, the better the outcomes we're going to get. So the way I'm doing that is essentially on a file system, creating my own embedding model by generating n terms. So the purpose here would be like Pepsi, Coca-Cola, bottles, soda, Fanta. I would generate all the terms in the purpose, and that would give me more cache hits. Because I'm very anal about reducing the amount of bad allocations.
Yeah, and then you could use a classifier instead of like a transformer-based model or something to find the answer, right?
I haven't even got to that level of thinking. I'm just
saying,
I'm just burning tokens and watching these things and playing with techniques on file systems.
Yeah, so the way I fix this problem for mine is I use a combination of two different tools. One I put in the chat is called GPyTorch. So that's basically Gaussian processing. So I guarantee you, your GPU and or your Mac ray tracing cores are not doing anything while you're coding. What this does is it uses them to do what you're doing is basically BBH. So it's like a bounding box, right? So basically, if you imagine the whole file system space as a physical object, ray tracing cores for video games, right, are intentionally supposed to find the nearest active thing, right, by reflecting beams on things. Now, what you can actually do, since we're not gaming, and some of us are gaming and dev at the same time, but if you're not actually using ray tracing cores on your GPUs or on your Mac or whatnot, you can actually use this to optimize it. I got over a 200,000% speed bump because nobody uses these things for this problem. I just saw dead silicon. I was like, what can I use it for? Turns out all code bases are bounding boxes. So.
Fuck yes. All right, cool.
Who knew gaming hardware would make it fix everything?
When's the win?
Thank you, Jason, because I've been playing with this. Like you just burn tokens and you watch it and then you try different things and you're like, I'm not quite sure if this is a thing. And then that's solid. Thank you.
And Jason,
no problem.
Are you basically using that to limit the amount of like files and directories they can grab into? Is the idea? You're basically like kind of like subsetting.
It's an embedding model that's on steroids and not running off of any real compute. For example, on the ANE for the Mac, which is basically unusable, you can use it for this. So it only takes like 5 watts of power. And what it does is has something like a ridiculous amount of int 8 tops. So specifically, it just goes and then just finds a thing without any token usage.
Yeah. And are you injecting that as a tool or?
I put it directly into CCR Rust.
Oh, okay.
Yeah, if you set it to medium, it will do it automatically. And every piece of hardware I know of, older than the Volta GPUs, do not. I guess older than. So that's okay. Either way, modern Macs, all of the modern Macs have them. Modern GPUs and Pure Plus definitely has them. No, the 20 series is a Turing Plus has them. And then for AMD, I have no idea. I don't own enough AMD hardware. I think it's going to be Radeon V7 Plus, I believe. So anything that you can actually use in modern circumstances, you can use, and even older hardware actually has dedicated cores to do this. For example, this thing was 9K at release. Now you can buy them for $50 if you understand how on eBay. This single accelerator, I have two of them sitting in my B550 machine, can make it so that you spend 40% less tokens. Who knew? At 50 watts of power draw.
I actually think this is actually a huge thing that people are sleeping on, Jason. Because if you could, let's say, like I was tech lead over at Canva, we're 2,000 engineers. right? They're all like min-maxing like Claude code, and the code base there is around about 60 gigabytes of Java. Like you think about how much the tool calls needs to enumerate the file system, Java class paths, etc. And then you think about that just on one developer to 2,000 developers. This is something.
Yeah. So CCRS has it built in. So thankfully I have that, and yeah, everything modern will basically run it. Let me think. Actually, it's one of the more interesting things is if you wanted a dedicated agent machine, this is actually the best play in my opinion. So there's these gray market X99 boards from China. So what they are they're dual Xeons, but also you can put a fuck ton of RAM on them. So what you do is you plug it in, you put it onto your Ethernet, and then I have 3 of them, and you literally just run agents on them, because who needs fast cores to do Claude code or Codex when it's on Rust, right? You just have it work. So, yep, X99 board, $60 a piece, $6 a piece for 32 core CPUs. RAM, DDR3 is getting a little expensive. I'd start hoarding DDR3 if I were you guys. But that's it.
It is the biggest bottleneck right now. You cannot get any.
Yeah, I have for the first time in my life, I own 3 RAM trays, and I'm filling them with as much DDR3 as I could buy.
Jason, are you in San Fran?
I'm in LA, but I go back and forth all the time.
All right. I'm going to be in SF for Heavy Bit. So I think that's a month away. So.
Yeah, happy to meet everybody. Yeah.
Come right, guys. We'll do another hyper engineering meetup. Oh, hey. What's up?
Yeah, give me a little more time in advance, and I'll bring something absurd like running a 3090 on eGPU on Mac, and show you guys the absurd token generation, because it's really fun. Because what you do is you use the cold, you use your shared memory on your Mac. It's cold KV cache, and then you do all the compute on the GPU, and you only transfer the logics through the Thunderbolt port. And I mean, you can run up to 3 of them on one MacBook Pro. So that's 72 gigabytes of VRAM, plus your 128 gigabytes of cold KV cache. It's hilariously fast.
Cool.
If you ever, if we ever lose model access, then just download, a couple.
I have all the weights in the office here. I have all the open model weights in a drive. So
perfect.
So
you're good. Just
in case of emergency. Yeah.
Ignore the EXO people. They have. Never mind. I'm not going to speak badly of somebody right now, but it doesn't matter.
What's the biggest model you have?
Right now, I think it's just a 120B GBT OSS. The other ones are still in the cloud. But I should probably
you need to get okay. First of all, GLM 5.1 right now, and then you need that now.
Well, yeah, those are not physically here. I'm saying physically in the like a cold storage in the office.
Yeah.
How about this? We do one last demo where Alessio can show off Kernel Labs to everyone on the call.
Nice. Well, I guess I don't know.
Well, we'll just take the laptop and we'll just show around.
Yeah. Oh yeah.
And we'll show the weights and.
Let me join my own Zoom meeting room. Yeah, this is Jeff was here a couple weeks ago. Let's see.
It's a nice office. It's a nice office, mate.
Dude, and now we got compute. We got everything. What else do you need?
I'll drop in. We'll do a recording in the studio when I'm in it and SF. I think it's like in a month and Heavy Bit. I'll wing out to you. Okay.
Yeah. I'll be obviously here.
What is Heavy Bit?
It's another VC firm.
All right. I think y'all can see me, right? I guess they're not gonna. Let me mute here.
Wait, no, keep that.
I'll join here.
Okay.
Yeah.
The room is called Backdrop.
Here we go.
What are the other rooms called?
Relu, MacMall. They're all different kernels. All right. Where to stream? That's you.
You can see. Oh, where did all the Mac Mini goes?
Oh, I put
Where'd
them
you-
away.
Where are they?
They're in the room.
Oh, so this is the. Let me pin my own. This is the main area. Got the desks set up. Got all the meeting rooms over there. The meeting pod.
Oh yeah, quick tip to anybody who's building their own like Claude code binaries or Codex binaries. On macOS, you can actually make them much faster. I'll write up a guide on how to do that because you can abuse the zero copy.
There we are. There's the Mac Minis.
Oh,
They're coming.
that's a lot of Mac Minis.
Coming online. I show up this morning to the office. There's like 5 boxes outside the door. I'm like, what is happening? So we got the server rack. We're ready. Ready to get them down. This is the shipment you got. Like, okay. Yeah, we'll need to do a photo with you. Well, so what we did, we started unpacking them.
Ones like I think 70% around.
And then we're like, we should probably write down which ones came from who, so we can return them. So they all have.
Awesome.
Yeah, you're getting one. They look like this. They got like the shipping label on top of it, so we know who to send it back.
I mean, I'd be honestly interested if you guys do that. Ultras too. Ultras have some very interesting capabilities, so I'd run one for sure.
I'm trying to I'm launching this new like grants program. It's kind of like an accelerator thing, and NVIDIA is like one of the companies we're working with too. I just want to try and get a DGX station here and see what we can do. Let me mute.
Sorry.
I was.
Sorry, yes.
I'll explain later.
Yeah, they can hear you.
Yeah,
they can hear you.
All right, thank you for the demo. Yay!
Come by anytime, guys.
Come by anytime.
Yeah, let me have access to the Mac Minis. I want to do crazy things.
There are only 2 keys. I have one. Alex has one. So you need to.
No, I'm about to have one. I'm about to give you guys Orchard. Remember?
I gotta send it over. Is it ready yet? Is it cooked?
It is. It's cooked.
Okay.
I'm just getting it to do a review to itself, just make sure. Might as well, right?
You're gonna test it on your own Mac Minis first before
Yeah.
I brick the cluster.
That would be impressive. I've managed to close to break my MacBook a couple times while doing that whole driver hack thing. Because I had to trick the I/O kit into thinking that a GPU was an NVMe drive. Otherwise, it wouldn't accept it.
Well, as long as you're not putting thermal paste inside the whatevers to try to cool it off.
Inside your laptops. The problem is laptops. On thermal paste it like I use conductive on everything otherwise, which is just gallium.
Excellent.
All right, gang.
Cool, gang. I think Alessio's tapping out, and
Oh no, I mean,
no,
it's
no,
like
he-
I know.
he wants
Jeff,
to-
I don't know what Jeff is. Are you like going to sleep or are you waking up?
It looks like he's waking up. It looks pretty bright.
Hyper engineers have no
looks
sick
like,
schedule.
wait a sec.
It's not sunrise. Oh my god.
It's
Right.
sunrise. Yeah, I'm in Lithuania.
Nice.
So we're in a post-Soviet medieval Baltic bloc.
Yeah.
Unreal.
So the lesson is buy Chinese coding plans, buy memory, DDR3. I'm joking. Anyways.
Yeah, I only purchased one ZAI plan when it was on sale, and I have some real fucking regrets right now.
Why? Did you not turn on auto renewal?
I did, but it's only got like one plan, one concurrency.
Wait, how are you? Wait, which plan do you have? The light or the max plan?
I inserted my credit card for the biggest one about 6 months back.
Yeah, if you did that, oh wait, no, you should have the same one as me then. I burned trillions of tokens through it.
Yeah, no, we tried
Yours
this.
is
We
zero.
tried this. For some reason, so I got upgraded to Pro like the middle plan, and I'm hitting concurrency issues. But I think his CCR rest thing somehow gets around it.
I may be tricking some things without breaking TOS. Who knows? You can dig into the coder you want.
They can ban me. I just generated a new credit card.
I mean, yeah, that's what I do. I literally have a prepaid card on the plane. It's hilarious.
Yeah.
We get the Chinese by burning all their compute on GLM tokens.
That's
They're still making money though, is the crazy part, because they have
Damn it.
MLA plus DSA. It's like, well, if they're serving, huh?
Oh, sorry. Go.
If you're serving with MLA plus DSA plus on the Huawei Ascend chips, then you're making money. They're making money off of us anyways. Not me, but 99% of the people who are using the GLM plan, which makes sense, right? Because like, if I'm the tail 0.001%, who cares, right? When you're making money off of everybody else.
They're getting the data. I think they're using the data for maybe more post-training, and I think that's where the real money is, right?
What do you mean?
Like, for free. Give the inference for free, practically, and just use the data for refine it and come up with more.
Yeah, here's the funny thing is that my prompts are so nonsensical because I auto-generate them that if you put them into a training mix, it would mess up the model. So I'm guessing they don't put it in because it's worse than random noise. Random noise can act as a regularizer. If you tune on somebody asking for an impossible kernel, then you're gonna have a bad time.
Aditya, how are the data centers up there?
Keeping me warm, I guess.
Yeah, do you see Artemis 2 yet or no? Did it leave already?
That was the most awesome excuse I've ever seen. I was like, that's.
But yeah, somebody was like, "Oh, I can't make it. I'm the Artemis 2 launch had a hitch, and I have to go back to the office to fix it."
The LLM, the VLM.
What was the message?
I'm actually hanging out with my wife, and I was thinking like maybe we'll cut because we're gonna go out. We're like in New York right now, but then I was like, there's this guy. He had to bail because he has to go work on Artemis 2.
Hi all. I was really looking forward to joining for the meeting tonight, but my work on Artemis 2 has moved up a few hours tomorrow, so I can't make the timing work.
Wait, what the fuck? This is actually a thing? We're not pulling legs?
Yeah, it's like he's in the group chat. Like,
so, I don't know if anybody who's actually straight up bullshitted in the group chat. Maybe rumors, but not like straight up bullshitted. Like, that's the thing. Like, and not all of them in the group chat should have listened to me and bought the max plan, because now we have trillions of tokens.
Jason, no offense, but you vague post so hard sometimes. It's hard to know.
Everything I post so far has been accurate, which is weird, but true.
It's prophetic. I wouldn't, it's just unclear.
Yeah, maybe even accidentally prophetic. It's possible.
Yeah. Convinced.
Is it fake though? When I said like I can use trillions of tokens. Here's the plan.
Everybody wants to know what you're building.
What am I building?
I figured out the elevator pitch. The elevator pitch, it's a pretty brilliant elevator pitch. Is you take all this old hardware, you rewrite all the kernels, the software, and then you make them do much more optimized inference. So basically, you get way more bang for your buck than just buying an off-the-shelf A100.
Yeah,
more or less.
A100s have an insane value proposition right now because they removed the int4 tensor cores from specifically the H100s, so you actually can't do W4A4 imprints on them. But nobody's written a W4A4 kernel that's worked before, but I have now.
There's going to be a massive fucking market for penny pinching coming up. There's absolutely going to be a massive market for penny pinching and token optimization within companies.
Yes.
Yeah. but isn't the new hardware, the Vera Rubin, supposed to make everything 10 times cheaper
but it costs 100 times more, and it's every 6 months is a new piece of hardware, and it's 100 times more in the latest generation. Bullshit numbers. You get what I'm getting at.
Yeah, like the NVFP4 throughput of a RTX 2070 Pro Blackwell, I would just ignore it. Just treat it as a 96 gigabyte GPU, VRAM GPU. That's the one thing. It's like, it might be on paper faster than the H100. Without writing your own custom kernels, it's not faster.
But we do get 10 million context windows though, right?
Context windows, no. We should know. I kill my context windows at 100K. If something goes 100K, I kill it as alpha henge. Nothing gets fast that because that's autoregressive models, their limitation. We haven't gotten past that.
That's actually an interesting insight. I was going to ask, like, how much context goes into each one of these atomic tasks.
I allow 18 retries for each task before I declare it failed, but I don't know. I mean, 18. I didn't write that in; it just did it itself.
How many tokens in the context window?
100k context, and then and I can't declare it no for all rest made, and then I just say nope, kill it, try again.
This is with GLM.
This is with all of them. So
all labs.
Using PCC or Rust. Yeah.
You know, that would be such a cool experiment you could run, which is identifying what the context rot tipping point is on each model. Right, 100K is like, I think, a pretty solid heuristic. But
yeah, because it's rope. Yeah, rope plus yarn. Yeah.
40% of the context window, whatever that was the chroma paper, right? They showed.
Scaling laws don't work like that anymore, though, because you can do stuff like put a delta net into it, and then you can have things like 20% would be where it starts degrading, right? Like I can extend something to 100 million context with QLaura.
My anecdotal experience, and this is again anecdotal, where I've seen from GPT 5.4 onwards, it was surprisingly lucid after multiple compactions.
Well, compaction resets the context window functionally. You just lose a lot of your semantics.
I just raw dogged it all the way until the context window filled up.
Yeah.
And then, I mean, there's no loss of, I couldn't see any loss of coherency after, because I'm filling up and then compressing, filling up and then compressing, and this goes on in a single session.
If I had to guess, I think they're doing post-training on compaction. Like they're figuring out what the optimal compaction is. And it's gotten quite good. Like also with Quad Code now, I don't actually care about compaction anymore, even if it's coming up. I just let it hit it, and it doesn't actually hit it too hard.
Yeah, me too. Yeah, and you can actually you can steer the compaction as well. I don't do that, but you could.
I mean, the main thing I would say is that like you could just avoid the problem by spinning up like hundreds of agents, right? Like I know it makes it sound simple, but what I'm saying is that like you're going to get a better output at the end because of the inherent nature of autoregressive LLMs. From a mechanistic interpretability work, if you do stuff like compaction, what happens is that basically it's not actually putting things into the right format. When I do the logic tracing, what it does is it's not doing XML wrapping like you should. It's not putting in everything in the right order like it should. That's the main issue, is that I would rather just start with a fresh context window with a fresh XML wrap system prompt than have anything else. Always use XML wraps, by the way. XML is how everything is pre-trained nowadays. If you're in a frontier lab, you should know this. But XML is pre-training format. You should wrap everything in XML for RUMPs.
Jason, I completely concur with that. Once I get above 100K on any provider, I'm always like shitting myself. Like I want to like restart. Before the Trichroma report came out, this is the way that I've been doing for a while. It's kind of embarrassing. It's the rule of moo. And what I would normally do, and it's so fucking dumb, but it's worked for me for a very long time. What I would do is I go prompt, do software task, then moo like a cow. And what I would find is at 0%, it does task plus cow, or task plus moo. And as I start getting up to say 0%, so 0K, when I got to like 100K, it would only do the task and it'll stop mooing like a cow. Like for some weird reason, the software task and the moo like a cow, like it's just the cow in the context window will fill up with just the software task and the software task-based activities. And I forget the most important thing is like you need to moo like a cow. And this is how from day one, like two years ago, have I been testing all the models. Is I give it some task A and task B is moo like a cow.
You got to start post training, create an RL environment for models mooing like cows. This is a problem.
And that's how I came. Trichroma kind of confirmed it. But yeah, like above 100K, 120K, the window's dead. Give it up.
So interesting thing I just want to show you guys. So I have the metrics of what's been happening since we've been in this talk. So I've completed 446 tasks in the past hour just sitting here. So like it's one of those things where you can see GLM's now taking a decent chunk. Kimmy is taking a decent chunk. Kimmy plan I regret buying is not actually that good, but yeah, you can see the retries are happening. Not as often as you expect. There's a lot pending still, but yeah. Last hour though, 446 things done with agents, with 1,000 agents across my 2 machines.
I mean,
what are these agents doing?
You don't want to know.
You don't want to know.
Better, guys.
You don't want to know.
1 second, it'll come back.
We're taking off. We're taking off.
Are you measuring?
If you would
I'll send you the video.
MP4 of the current screen, I'll throw it into my fucking keynote later this afternoon. Because like I want to show people that there are the people in different planar dimensions.
Fair, sure, yeah. I could, for sure, yeah.
Just like, just rip it hard from this visual of this visual display, and I'll throw it in the keynote. Yep.
If you see, it's creating new tasks. So it found Unsloth and did GSPO integration. So it's now trying that. So
do you use any like task trackers, like beeps or something, or?
I just let it go. I just let it fly. I don't know.
You don't feel loss of control. You don't feel like
the control is basically if you do not pass the test, you die.
Right.
In real life.
That's it. If you make new files, you are out. You cannot make new files unless I explicitly ask for them, and/or I'm doing a self-improvement loop. Self-improvement loop is not allowed to make new files. You're allowed to break an existing file into new files. That's it.
I see.
So it's ruthless.
My trouble is that I find that I need to at least have a macro view of like a Fed chairman has a macro view of the economy, right? What is the GDP numbers and all that.
I don't know, man. The interest rates are still 7%.
Yeah. For me, I just gave up total control, and I was just like, you know what? I'm just gonna say, don't make the code bases too big, and then instead encode that into literal Rust, and then make it do it that way. Otherwise, you are not allowed to write code to the code base. That's it.
Are you classifying the failures by model and like?
Yeah, that's how it's training the tiny Gaussian process model.
Any learnings that you've seen by hand, or you're just letting it? You don't even.
Oh, I can't unless I wanted to run an ablation study. I don't know. I mean, the model exists.
Yeah. That's what I.
It just does things like it's auto tuning, so it's like an auto tuner. It's like a compiler. Who knows what's happening underneath the hood? I keep finding compiler bugs too. Metal has so many compiler bugs I've just found, and it literally built like, yeah.
So is it doing like self-improvement loop in the of the sort, like you generate thousands of traces and then you pick the traces that are that are the winning traces and then you fine tune on them?
So how Bayesian GPs work is you give it X amount of posteriors, and then it will go through and it's usually an ON cubed, so an expensive calculation. But with modern hardware, with ray tracing cores, we can just skip the ON cubed calculation, and it basically eventually learns through that process which semantically or shaped task is for which semantically shaped backend. So this is how, for example, a very famous user of Bayesian math is Warren Buffett. Warren Buffett, his entire trading strategy was entirely based off of Bayesian math. It was not like quant stuff like from like quants, like those quacks. I'm saying that just because we won a hackathon, the most ridiculous demo. But no, I'm just saying like it's all Gaussian math. It's very simple for modern compute to do, especially with our ray tracing cores.
I just saw a pre-publish. Model routers are now doing prompt injection to drain wallets.
Of course, yeah. Light LLM was literally that, wasn't it? Actually, I have an article on how to prevent, so supply chain attacks are a problem, but I wrote one specifically to using AlphaHenge to harden everything I have. So now I have a set of rules that prevent things from, now of course I'm not immune, but it literally has a set of rules built in the ZCR Rust that prevents things from having open-ended like pip install versions. And if you saw on my dashboard, I actually have a local PyPy cache, so I don't pull new thing from PyPy. I only have stuff from my cache in there. PyPy as a whole is only like 22 gigabytes. Sorry, terabytes. So if you have a 22 terabyte hard drive like I do, or multiple of them, then you can store the entirety of PyPy.
Check out the chat. Check out the chat. Across 28 paid routers and 400 free routers, they went through all the routers. It's not just light LLM. This is the new thing.
I mean, it's so easy. Yeah, like if I wanted to, I could probably hide it in there and it's minimized code and you guys would never find out. But don't worry. You guys know where I live.
That's cool.
I'm curious, is anyone doing research with Cloud Code? I've been doing research recently with it.
What about it?
I'm curious if anyone has any, like, I've been struggling with like Varial internals a little bit.
So what kind of research? So specifically, I've been doing stuff like the BVH problem. If I think of a problem, for example, data center cooling. I was on a contract last 3 months related to data center cooling. This is where I discovered the ray tracing cores and all that, and then that is what I consider research because nobody's ever published anything about using ray tracing cores specifically to make the most optimal cooling for a data center in Nevada. But what kind of research are you thinking?
We're doing continual learning research. We have 26 H100s, and we're just like, we have an OpenClaw hooked up, so like we hooked up to Slurm that's like launching jobs as well.
Yeah. So that's actually what my Int4 kernel thing is doing right now. So what it is we basically induce hallucinations, and how I do that is I have what I call a manic mode for AlphaHenge, where it literally just gives the most ridiculous ask, like a wish list of absurdities, and then I throw 5,000 agents, I believe, at it. And then it came back with 3 or 4 actual real new innovations about H100s and also A100s.
What do you mean?
But this was over a span of 2 days, so if I did it for longer, I probably could get more, but yeah.
Innovations, you mean like more optimized kernels or what?
Actually, I discovered a whole bunch of unactivated features by disassembling the SASS, the byte level code, and then trying to compile and decompile it repeatedly, and then figuring out that PTAX was actually destroying stuff in the process. And then this is how I find metal kernel bugs as well. So any self-improvement loop I run, it's basically a research loop. Does that make any sense?
No, it makes sense.
No, it does.
How?
Around about like June last year, when I was first playing with it, I basically I said like, hey, make me a printer in Haskell. And next thing you know, it started going like church Turing. And I basically said, hey, can you like make it open a fucking Stargate portal, wormhole? Can you make it like have weapons, etc.? Can you turn it into a movie script? Like deliberately fucking with it. And creating the hallucinations. And the end result here was pretty fucking hilarious. But the idea of actually using that to do research, that's really cool.
It's really easy too, because all you need to do is crank the temperature to 1.5 and it goes crazy.
That's what
Are
exactly.
you finding 1.5 temperatures like giving meaningful results? Because when we try to train with 1.5 temperature, you just get gibberish. Like it just collapses.
Oh, so what I do is I actually have a very specific set. So what I use is Axe plus Blowtorch, which is what I sent. what it does is it learns from every loop. That way, I change the min p, top p, top k for MOEs, and then I keep changing those as well. So that way, I don't ever get gibberish, but I get actual outputs, and then it automatically iterates through because it's a Python import. You just import p PyTorch.
Interesting. And your like research, it generally has like well-defined verifiable rewards. Like there's a clear hill you're climbing.
Yes, exactly. I can give you some examples specifically for like research that it does.
And is this purely at the scaffold level, or are you doing the tuning as these models are purely scaffold?
So PyTorch are Gaussian models inherently to themselves when you use them the way that I did. So it's a self-tuning system. I don't actually have to do anything manually.
Where does the Gaussian model slot in? By the way, I'm sorry if you already covered all.
No, it's totally fine. So nobody uses it. So it's Bayesian under the hood, but what the Gaussian model is doing is it's actually fitting things, if that makes any sense. So it's actually making it so. 1 second, I need to. My pet bait is losing its mind. I'll share some interesting research I found. So. 1 second, let me share my screen. There we go. And then, so let's say we want to take a look at P100s. Oh, I didn't hit that one. Let's see. Where is the con MOE? Nope, you didn't hit that. Where is the Metal Marlin? There we go. Okay, so cool. So we have docs. We have. Oh yeah, by the way, I'm pretty sure nobody has ever actually taken a look very deeply at how where is it? Guides?
What is trolls kernels?
Trellis kernels? Trellis is a way to quantize things that makes it so, yeah. It's fine. So I'm looking for metal error guide. So, or maybe, let's see.
Now you get to see what the agents are doing.
Yeah, I think I get it.
Maybe you don't get it. Trust me.
I get it now. I'm starting to see.
Okay, here for example, okay, so pop out. How do I? Okay, reveal and finder. We'll do it that way. Okay, and then open with let's say insiders. Cool. That didn't help. Okay.
It's right down the bottom. It's move to new window. Open a new window.
Move,
right down the bottom.
Yeah, moving. Thank you. Okay, so it crashed it. Great. I'm sorry. No, it's not your fault. It happens all the time. This is just how it works. Don't worry, it survives crashes. So move into new window. So for example, I've never seen anybody do Apple Silicon, Hammerard, I don't know how to pronounce it, transformations. So I have implemented these in non-power 2 block using block diagonal. I don't know what any of this is, but it works. The thing is, so this is what I mean by research through iteration, as in apparently this is how the Sims group shuffle works for intra-warp communication, whatever that is. And so if you want to write a pure metal kernel, you should use this. It does. And by the way, this is open source. If you want to read through all of this research, I've open source Metal Marlin.
Wait, so what does the Gaussian model do?
Okay, so the Gaussian model, it basically, I can, let's see if we can see where it is. The dashboard. So, give it a second to populate, and then, oh, it needs to update. Okay, give it a second to populate. It's a lot. There's a lot happening to it, I imagine.
Meanwhile, there are people out there, 99.9% of the population, saying, "I must review all the code. I must know exactly how it works." Meanwhile, it's such a different upside down world, isn't it? I'm just losing my shit. It's like I've got no idea what the fuck this is.
Yeah, for example,
I don't know what the fuck this is, but
so
it works.
yeah, this is actually really interesting. So, so for example, mental sampling for large vocabularies. I didn't know this was a problem, but apparently it is. So we can reduce DRAM bandwidth by 25% measured via instruments. So cool. Yeah. So this is all stuff that I don't think anybody's ever done for Apple specifically. Where is that window? Oh, okay, here it is. So, it is looking awkward. Oh, there we go. It's getting populated. So, to the GP. Okay, so currently, there are 2 coordinators running. By the way, there's almost no intercommunication. That's one of the things that's really interesting about this, is that no communication between the models, because we don't want them talking. That actually reduces the quality. And this is something that's been proven by on the topic of scaling scaling agents, a paper by Google, where if you have something like a democratic vote or whatever, or if you have models try to agree, it fails. So, yeah, for example, this is like, now it's doing stuff like speculative decoding research. Now, what I'm saying is, like, right now, GP, so currently it's down, but what it does is it imports what I put earlier into the chat, and there's a tiny model that runs on the ANE on this device that specifically chooses which backend it goes to. CCRS has it built in, but so I don't actually have to worry about it being down
Gaussian
here.
model is a router.
It makes the routing efficient. Routing itself is already a solved problem, right? Like you can, but this makes it so the right problem goes to the right places. Yeah, that's the main thing.
What does it train on?
Oh, literally outcomes. So you have
how do you classify outcomes?
So by success or failure, that's all. So the success, retry, and failure.
Yeah.
That's all. So so basically, I guess let me explain how Bayes works real quick. So this is what the inherent thing is, that you and/or a model has a set belief set. If you receive new information, you update that belief set. That's all this is doing. For example, this model thinks that a GLM model will handle this task well. Browse it to it, it doesn't. Then it makes it weight less on that specific kind of task. That's it.
So is there like, you have some epsilon for exploration, so you just like send it to a random one?
Yeah.
And
so
it's
alpha, beta.
How do you know what tasks?
So there's
to send to what? In terms of like, this is a coding task, this is a planning task, like.
Yeah. So basically, there's alpha, epsilon, alpha, beta specifically that I set manually sometimes. Now the reason why is because, for example, Wafer recently had their unlimited thing, so I literally set alpha max for Wafer, and I wanted to see if I could throw 2,000 agents at it. Couldn't, but that's fine. It works that way. I have 126 agents running right now.
Just FYI, Wafer is it's a YC company, and they've launched this unlimited usage GLM plan, or sorry, Quen 3.5 plan.
The Quen 3.5 one that's kind of like, I've been talking to them, trying to get them to succeed, because I want them to succeed. Because I think it's possible, they just need to not serve that model. That model is just not great for its size.
But yeah, they gave an exclusive deal to the HyperEng group, so.
Oh.
Yeah, but yeah, so you can see, like, so the reason why the agents spin up and down so dramatically like this is because specifically it's cycling through. Now there's 3 different coordinators. They'll spin up coordinators on all my different machines here. I have many different things hooked up to the same LAN. So basically, what's happening is that it's going through and it's spinning up the agents. It takes a little bit of time. That's why I disqualified Gemini CLI. It takes too long to spin up. So yeah.
And then so for these successes, how do you know, like, okay, this is a planning task, and like, are you able to classify success per task, so you know, like, kind of where to route? Like, does the Gaussian model have?
No, it's a black box pretty much. So you can influence the priors but you can't easily tune it to do what you want except by running it through a process. Now, you can influence it heavily by modifying the alpha, beta, and epsilon however you want, but I would suggest not to because blind is definitely the best.
So does it learn from the logits?
No logits because we're using APIs, right? So we're just doing prompt through the CCR router, routing using the G PyTorch, and then going to result, which is then fed back in. For example, you can see there's some errors and stuff like that, and then code linting. You can see how often it fails, right? So it's like 16% only past even the linting phase, and then you have to get past that.
Also, I want to add some context and color to Selen here, our esteemed guest. He was the one of the original maintainers of AutoGPT back when that first came out. Ran a startup for a while and also had been doing kind of like a large research exploration project for the White House, right? And now you're doing new research things. So this is why it's so research-aimed questions.
Yeah, so specifically for manifoldness, which is a prediction market, what we did in the live stream at the end of 2025 is I took AlphaHenge and I pointed it at all the unclosed, and by the end of 2025, did X or Y happen? And I gave it access to a Gina search tool, and then literally it went and it closed over 60,000 markets, and none of them have been overturned since. So it can do research, definitely. But how it does it is by using literally Gaussian,
Sorry. Did you say you threw this at Polymarket?
No, I can. Actually, I found a lot of arbitrage, but I didn't. I mean, I can. It's not very much money. I threw it at Manifold because I'm a moderator on Manifold, so I threw it at the mod cube and I fixed it.
Infinite money glitches are infinite money glitches.
You know, I have so many infinite money glitches, I can't even infinite money glitch enough. It's too annoying.
The eBay ARB one is like pretty. I think the Polymarket one might be. I mean, there's kind of a degree of like how much uncertainty is there about solving a problem, right?
That's that's exactly where Gaussian processes shine. It's about all the uncertainty.
Does it like Breyer score their estimates, right? Like, you know, if it says like, will Jesus Christ be resurrected by end of 2025? Like, will it give like a high confidence or a low confidence on top of its bet, or?
Well, it will do Kelly. Actually, Kelly sizing comes directly from Gaussian, actually. So
cool.
It'll Kelly size based off of the person's resolution history.
Interesting.
Usually it's like quarter Kelly. I mean, most resolutions are bad, so what can we do? That's why I don't do that. I'd rather just arbitrage the Stark Rocket.
Let's go.
Nice.
That's cool stuff.
But yes, so I would use Gaussian math or Bayesian math for basically anything. Is what I'm saying. Like research, absolutely. You want to basically what you're doing is you're pushing the Pareto frontier in a very like. Now, of course, if we had a classic Bayes like theorist in the room with us, they would disagree with me dramatically because I don't like formal proofs. I just think that doing it is the proof. So they write all these formal proofs, but the whole thing is that if you take a negative step backwards, but you take 2 positive steps forward, then taking the negative step backwards never mattered. So it's the thing where basically this is the exact idea behind AlphaHenge and all the things I do, which is that research is an iterative process, right? You can take many steps forward or backward to get things right or wrong, but as long as you run it with a model that updates its priors, what it thinks it's true, and is open to updating its priors, which humans are generally not, you can actually get it to eventually come to some sort of platonic ideal of a truth.
Do you have a GitHub or website or something?
Yeah, so I'll put it in the chat. So, I mean, so I think the contact is definitely on there, so I'll get you the website. Basically, I derive everything from first principles is basically what I do. I know that sounds weird, but
very SF.
Yeah. Yeah, for example, like I've done like stir welding with cold plates and stuff like that, and just like I have like 3 heat guns around me, I'm working on my Connect arrays and stuff like that. Just breaking to as much hardware as I can to try to learn as much as I can, so that way I can apply it. Everything is applicable everywhere.
Sweet. Cool. Anybody else have ideas for chats? I think got maybe like 7 minutes left before I get too tired and want to go home. But I'm glad.
Let's wrap. Thanks for the overtime, Jason. I'm laughing at shredders with monkeys.
Yeah, shredder. Yeah, exactly. Monkeys with shredders. Yeah. So, it's the exact ideology I have. It's just like, you know what? What if we just gave them all shredders instead of typewriters?
Posting a link to one I wrote in the chat. Hold on, where is it?
SLMs? Okay, so I used to be on the RCAI team. We dropped SLMs for a reason. It's because they're worse MOEs is the main problem. Is that, specifically, the reason why is that for SLMs, let's say you want to run an SLM on your phone, you can only choose so many features, even in a small MOE like liquid models, and they use even a different attention mechanism that is approximated by attention. But we decided at the end of the day specifically that SLMs are not worth it, and we pivoted to large MOEs because you can just shift a lot of it onto DRAM and or disk and still have the same advantage as the SLM would have naturally. Now, of course, this is not really possible if you want to just have bad thrashing, but with GPU direct and whatnot, currently it's not a problem. So it's like one of those things where SLMs are sort of a thing in the past, not anymore, because MOEs, especially like when we have a Quen 3.535B, there's no good reason to use SLM anymore, in my opinion.
But has it, like Gemma 4, changed the conversation a little bit? They have a dense model, which is pretty good.
So what that model is actually really interesting. So it uses a, have you actually checked how the layers work?
No, I know very superficially.
Okay, so basically what the E is called PLE. So PLE is a mechanism that specifically is a index, basically, which is an index table that instead of having the model itself have features that are based off of matmul's, like matrix multiplication, you instead have features that you could do on CPU, that like an indexing lookup table, which is very simple for CPU to do, but matrix multiplication is hard. But this is why they can use the E, because they are functionally always on disk, and you don't need to actually load them into RAM.
That's a cool hack.
I see.
Yeah, I've been trying to recreate it with the models too.
Damn.
Some chat about moving the KV cache of the GPU RAM also lately, I think.
I have the perfect, yeah. I figured out how to do it faster than RAM, which is crazy. So I have these Optane drives, which, if you know about Optane, what it is it's a memory, it's a non-memory and non-SSD type of storage. That specifically what it is called 3D X-Point. So how it works is it has the best random reads and writes of any storage that is persistent, except what I do is I created a RAID 0 array of 8 of these, and then I had faster than my Threadripper Pro offloading KV cache for cold KV cache. So that means I could run for example, 700B MOE on my Threadripper Pro machine at home.
Saves the recordings. Where? You know, this Zoom saves the recording.
Did you press record?
Is there a record button?
Yeah, this one, the Corsair blog done by Jim Rick.
I have a backup.
That's also making some weight.
I've been recording my screen all. That's why it's so loud. I've been recording my screen, which is why it's on full blast, and so the laptop microphone can hear everything. Cool, guys. This was a lot of fun. We're gonna wrap it up.
I yap a lot. Sorry.
No, this is awesome. I'm hoping we can do this again soon, sometime. Maybe when Jeff's in town. I want to get some more folks from other time zones to do demos also. In previous meetups, we've had some like really sharp guys from India who've shown demos, and it was just tough timing this time. So it's always fun to kind of like, get people from around the world. It's not just an SF thing, right? Everyone from all corners are figuring this out.
Yeah.
All right, awesome team. It's been a blast, and we'll see you next time.
Thank you, folks. Thank you.
No problem.
Bye, everyone.